Hello again. This is Eric Miskell with EMSNOW on the show floor at Apex 2026 in the Co-Young booth with the green behind us. But it's also, I was just told, part of the Indium color code. So this actually works out very well since I'm talking with Kevin from Indium today. Thanks for taking some time away from your booth to come over and educate us all a little bit about what you have going on.
Thanks for having me.
Absolutely. Listen, there were three particular ones that we wanted to that you're highlighting here at this show. The first one being, just kind of tell a little bit about each. So Durafuse LT is one of those.
So Durafuse LT, it's an alloy that we use in our solder paste that enables a reduced peak reflow temperature.
Okay.
And that's favorable. It's a growing need, I would say, especially large BGA warpage. So as the need of AI, high performance computing is growing. I'm sure you've heard about all the data centers being put up. They require these very powerful chips, and they just keep getting bigger and bigger. And it poses a challenge when you try to then attach it during reflow. As you heat them up, they might have these complex warpage shapes.
Yes.
And it really causes problems when you want no defects. You don't want head and billow or non-wet open. So by reducing the peak reflow temperature, you typically are reducing the level of warpage you're seeing. So it's a way to manage that warpage and reduce defects in these type of applications.
So you mentioned the application of the data centers and all the servers. But one of the things that I see in the industry is certainly it's becoming more complex, and right, they're getting smaller, they're getting closer. That must pose challenges for what you're doing.
Yes, it's the high density, fine pitch boards. It's another reason to use Durafuse LT is as you kind of try to pack everything in, and you still need that high computing power. So typically more power means more heat is generated. So the boards need to be a little thicker. The components might be a little bit more robust. But with that, then you have this challenge of uniform thermal heating. We call it, thermal gradient on the board. So if you have a larger board, large component here, very densely packed, it's going to have different peak temperatures across the board, which is typically not ideal when you're reflowing. But Durafuse LT, because it can reflow all the way down to 205 Celsius, but also all the way up to 260, has a very wide window. So even if you have this gradient on the board, it basically enables these complex assemblies to be built without redesigning the board. You change the alloy, you change the reflow profile, and you're able to build these boards with...
Right. The other one is the Durafuse HR, right? So tell us about that one.
So Durafuse HR is high reliability. Durafuse LT is low temperature. And they're part of the Durafuse family, which really that means is we take two different alloys and we blend them into the same solder paste. So typically a solder paste is just SAC 305 with a flux. This time we're doing two alloys in a specific ratio, blended together. And that's what's enabling these unique properties. And the Durafuse HR is designed for high reliability needs, specifically thermal cycling or thermal shock. But the thing that makes it different than what may be out on the market is it's also low voiding. So typically a high rel alloy, because you're doping it with all these other constituents, you're trying to make it stronger, more rigid, that you end up with a 6 or 7 element alloy system, which poses challenges specifically for voiding. But by utilizing that dual powder technology, we're able to achieve a high rel alloy, but reduce the overall voiding.
That's interesting. Now, how closely do you work with the the convection oven manufacturers?
We do keep in close contact. We have a few different companies out there that we touch base with. We do joint projects with. So it's definitely on our radar, our R&D and our technical support team, as well as my group, product management.
Because the effectiveness of your product is really contingent on how well those operate and how well they process.
Yeah, especially the Durafuse family. The reflow profile is very critical. We've done extensive work to really fine-tune them and understand, for which application, how to reflow it. If you're looking for lower voiding, or if you have these thermal gradients, whatever it may be, we've done a lot of work to understand that.
Yeah, no, I hope so. Listen, the other one that I know is, and you said it's a flux, the Indium 12.9 HF.
Yes, so Indium,
do tell.
12.9 HF, Indium 12.9 HF is our newest no-clean ROL0 material. And the interesting thing about it is it's compatible across a wide range of alloys. So it works on SAC 305, but also other SACs, as we see a growing need for low silver alloys
Yeah.
as the price of silver has increased. Depending on your reliability needs, you can reduce the amount of silver in your alloys, and it's a cost-saving initiative there. It's also compatible with Durafuse LT and Durafuse HR. And I think a lot of people in this industry are familiar with our Indium 8.9 HF. It's been around a long time. It's a proven material. 12.9 HF was designed to be better than 8.9 HF every step of the way. And it's designed specifically for these fine pitch, high density assemblies that require more challenging print transfer efficiencies or more challenging area ratios.
Okay. So that's interesting. So as you introduce the new one now, do you stop making the other one, or it continues?
It'll continue. The thing about
You're transitioning though more to.
yes, so new customers or new projects may come to us where we typically would have said 8.9 HF is your material.
Yeah.
Now we say, hey, we got something even better,
No.
Indium 12.9 HF.
But they would still need to qualify that for their process.
Yes, and that's the other thing is any new alloy, any new flux, there is typically a long qualification. Everyone wants to do their due diligence and ensure it's going to work and work for a long time. So there is like a buffer period where we would probably see the one phase out and one grow over time.
Now we've talked about a few of the issues kind of driving the industry, with the boards becoming more complex, right, and denser and everything. What else is driving the industry? I mean, you also just mentioned silver pricing, right, going up. That changes, an element to, not necessarily chemically, but certainly from an economic perspective. But what are the other things driving sustainability? Is that an issue that's
sustainability? There's definitely companies out there that are focused on it, and Durafuse LT and HR actually are both able to improve sustainability depending how you look at it. So Durafuse LT, you can reduce your peak reflow temperature. So if your reflow oven typically was operating at 245 Celsius peak temperature for 7 days a week, 365 days a year, multiplied by however many ovens you have, now you're reducing it down to maybe a 220 peak. And there is a reduction in energy usage, which that one is a cost saving, but more importantly, some may argue it's reducing your carbon footprint as well.
And especially in places like Europe, where the energy prices are so much higher, that's a challenge for the industry over there, I know. Less so maybe here in the United States. So it is. And I know that's a big issue for Europeans. So, well, excellent. I feel smarter at the end of this, Kevin. That always makes for a good interview. So appreciate the insights. Thank you. Hopefully we do this again sometime.
Yeah, thanks for having me.
Kevin, I appreciate it. Thank you, sir.
Thank you.